Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to take Basic Thermodynamics Module 2, Lecture 2, First Law of Thermodynamics. The first law of thermodynamics, what it is, and there are two statements of the first law of thermodynamics, and those two statements we are going to take, which are applied for the closed system undergoing a cyclic process and applied to closed system undergoing a non-cyclic process. Those two statements one by one we will discuss here. First law of thermodynamics for a closed system undergoing a cycle, that is a cyclic process. For a closed system undergoing a thermodynamic system, the first law of thermodynamics states that the net heat transfer into the system is equal to the net work done by the system over the complete cycle. In the previous system, we have discussed the Joule's experiment, and there, as we know, that one the heat transfer is equal to the work transfer we have taken, or work transfer is equal to the heat transfer we have taken. If more than one quantities of the heat and work transfer are there for that particular system, their summation or cyclic integral we have taken. The same is here. The first of thermodynamics, there the net heat transfer we have taken. The net heat transfer means the summation. The net heat transfer into the system. Here the heat is transferring into the system. That is equal to the net work done by the system for that complete cycle. Here that can be expressed mathematically as the cyclic integral of heat transfer is equal to the cyclic integral of work transfer. That is, cyclic integral of heat transfer is equal to cyclic integral of the work transfer. The first law applies to a closed system and the thermodynamic cycle, but not to process. It is not for the process, it is for the thermodynamic system. If different units are used for heat and work, here heat and work, those are to be in the same unit, then only we can take the cyclic integral of heat transfer is equal to cyclic integral of the work transfer. If that is not there, these two are in different units, then a proportionality factor called mechanical equivalent of heat that we have taken in the Joule's experiment as a Joule's equivalent, same thing, denoted by the symbol J is required. So that first law may be written as Joule's constant or a mechanical equivalent of heat into cyclic integral of heat transfer is equal to cyclic integral of work transfer, where the Joule's equivalent or a mechanical equivalent of heat is multiplied with that. Then further here the in MKS unit J is 427 kg of meter per kilocalorie. For the SI unit, both are in the same unit. Then there is no question of this Joule. Therefore, the Joule is 1 Newton meter per Kelvin. In SI unit, both heat and work are expressed in the same units. Then, therefore, it is not necessary to use the proportionality factor, that is 1 Newton meter per Kelvin only. Therefore, only these two we are going to use. Then this is the first law of thermodynamics for a closed system undergoing a cycle or a cyclic process we can take. For the cyclic process, then these two, cyclic integral of heat transfer is equal to cyclic integral of the work transfer. Both we can interchange from the right hand side to the left hand side also. Or we can take the summation of work transfer to the summation of heat transfer also. Then this is for the undergoing the cycle. Then further if you move, first law for a closed system undergoing a change of state, that is a non-cyclic process. For that, for a closed system during a cyclic process, the sum of heat transfer is equal to the sum of work transfer, already we know. Summation of Q is equal to summation of W. Then, but for a closed system during a non-cyclic process, that is undergoing a change of state, the work transfer and heat transfer may not be equal, and this difference is accounted for by the change in internal energy. delta U, or simply called as the energy of the system. Here, for non-cyclic process or a system undergoing a change of state, the summation of work transfer is not equal to the summation of work transfer. Then the difference is there. That difference is the change in internal energy. And that change in internal energy is taken into consideration. That is, all the heat is not converted into work, and remaining energy what is there, that is in the form of change in internal energy or energy of the system. And here Q, W, delta U are expressed in the same units in joules. All these are expressed in the same unit as a joule. And this also we can write in other way also, that delta U only we can express delta U is equal to that, the same thing, the Q minus of W, we are going to take the same equation, we can rearrange, and that can be expressed like this. The first law of thermodynamics for the cyclic process and the non-cyclic process, separately the equations we can take. This is about the first law of thermodynamics. Thanks for watching. If you like, share, subscribe and comment.